Here's the key for lesson 7 assignment problems. For the most part, they're pretty straightforward, and I think you guys can go through and check to see what you did and what the right answers were here. So I'll let you do that for most of them. I just want to go down to number 9. Okay, so I'm gonna go back to the original question here. So number 9 says an object is thrown downward at 35 meters per second from a great height. What is its velocity after 5 seconds? So first off, I just want to draw a little picture here. Make sure we got this figured out. So you got person up here. I'm a really bad drawer, you can tell. But anyway, throws the rock downward. And I think what most people's intuitions are is that if I throw the rock downward, it has to have an acceleration more than negative 9.1, right? Like we said before, everything like up in the air, right? Throw it up or whatever, like it has an acceleration downward of negative 9.81. But if you throw it downward, most people would think, well, I must have a bigger acceleration now because I threw it downward. It's actually not. Remember that throwing this thing downward doesn't change the fact that it's changing its velocity at a certain rate. The only difference here is this thing started with a bigger VI. So VI, instead of being like 0 if you just dropped it, it was at like 10 meters per second, or negative 10, I should say, because it's going down. That's the only difference, though. The rate at which it changes its velocity after that point, after I let it go, is the same. So for number 7 here, or number 9, I mean, sorry, one thing that might have thrown you off, well, two things. You might have forgot the negative symbol for the V1 or the VI because it's downward. But then the other thing that might have messed you up was that it's still negative 9.81. So everything's the same. We just have this negative 35 now. All right. Number 10. Number 10 is pretty straightforward. It's like ones we've done before. You do need to know, though, that for like part A here, velocity at the top is going to be 0. That's important, right? So that's that whole trick where even though it doesn't tell you what the final velocity is, we know at the top it's going to be 0. So you can figure out your time for it to get to the top. And then the second part here, you can figure out your time it's in the air just by doubling this number. Okay. And yeah, C, we've done ones like that before too. So just kind of check this out to see if it's right. Okay, number 11 says Mr. and Mrs. Light. Mr. Light, by the way, is the one who made these these really awesome physics documents that we're using. Anyway, they are vacationing near the cliffs of Dover in Britain. Mr. Light throws a stone upward from a cliff, while Mrs. Light throws a stone downward. Explain how the acceleration on each stone is the same, regardless of whether it is initially moving up or down. So for that one, it's the same type of thing I was showing you before, right? If you throw it down, the rate at which the velocity is changing is still negative 9.81 meters per second squared. If this person threw the rock upward, then the same thing is true. It's still changing its rate or changing its speed at a rate of negative 9.81 meters per second. But this one where it throws upward is going to go up and then down again, but the acceleration was down the entire time at negative 9.81. For number 12 here, it says a projectile thrown up in the air, or for a projectile thrown up in the air, explain why the time taken to travel up to the maximum height is the same as the time to go back down again. Well, it's really just because the acceleration for this thing was negative 9.1 for the first half, and it was also negative 9.81 for the second half. So everything's actually perfect. If you think about this thing, it's going to be going the same speed at that point as it is at that point, and so forth. So it's actually like a mirror. You can actually, like, everything's going to be the exact same. And then the last question here says, what variables determine how long a projectile is in the air? So what you should do for this one is we want to look at the formula to kind of see. So time is equal to VF minus VI over acceleration for our object that goes up and then back down again. So you can see that time is going to depend on VF, VI, and A, right? That's what it depends on. And you could really actually say that it only really depends on VI and A, because actually, let's say this was VI. It's going straight up again. Since everything, like I said before, is kind of like a mirror, VI going up, that's actually the same as VF going down. They're exactly the same in magnitude. They're just different in direction. They have opposite directions, but they're equal in magnitude. So this thing really only depends on VI and A, because VF is really just the same as VI. Okay, hopefully that made sense. That's it for that lesson. So we'll carry on lesson 8 in the next video.